Welcome to our unit circle prep. What we're going to be looking at today is two different things, but it's going to combine over the next couple weeks in order to form an understanding of the unit circle. And the unit circle is something really important that you're going to be using a lot next year. It's where we get the definition of trigonometric function, sine, cosine, tangent. Anyways, it's a lot of different things, but today we're just going to be focusing on special right triangles, which you looked at in geometry. And then we're also going to be looking at circular measurement, which is on a coordinate plane. It's measuring angles kind of around the origin. So let's kick it off with special right triangles. Special right triangles, you guys looked at last year in geometry, and you guys actually did some proofs for the side lengths are always going to be the same ratios when you have a 45, 45, 90 triangle or when you have a 30, 60, 90 triangle. So we're going to kind of quickly look at this. So 45, 45, 90 triangle, it means that you have a 45-degree angle, a 45-degree angle, and then a 90-degree angle. And what we are worried about, what we're going to be mostly using, is we're wondering what are the side lengths when the hypotenuse is 1? Now, there's different proofs you can do. Kind of the simplest thing to look at is to say, okay, so if it's a 45, 45, 90 triangle, I know that the side lengths are equal. So let's just call them x, maybe x and x. And then by the Pythagorean theorem, you know that x squared plus x squared has to equal 1 squared. So basically 2x squared equals 1. If you isolate your x, let's divide both sides by 2. So x squared is equal to 1/2. We'd have to take our square root. And then we get that x is equal to, let's put it this way, the square root of 1 over the square root of 2. You know the square root of 1 is 1. Square root of 2 is not very nice. But if you remember, we hate having square roots on the bottom. So we're going to rationalize. So we end up with square root of 2 over 2. Now, you do not have to do that proof. The main important fact is that if you have a 45, 45, 90 triangle, if the hypotenuse is 1, then both of the sides are square root of 2 over 2. Square root of 2 over 2. If you forget that, you could do the little proof that we just did, but really, these numbers are what you need to know. This is what you need to know. Every single 45, 45, 90 triangle that has a hypotenuse of 1 has these side lengths. So take a second, let it marinate. Those are the numbers you need to know. Now, let's look at a 30, 60, 90 triangle. 30, 60, 90 triangle. That means that we've got a 90-degree angle. This is going to be 60 degrees because it's the bigger angle, and this is going to be 30 degrees because it's a smaller angle. And if you notice, the smaller angle is across from the smaller leg. Now what we're looking for is I'll just give you the proof for those of you guys who want it. Let's imagine, or not imagine, let's say this hypotenuse is going to be 1, and I want to know what are the lengths of the legs. So one way to do that is to, let's just imagine this was an equilateral triangle, a 60, 60, 60 triangle. So if this is a 60, 60, 60 triangle, check it out. This would be 30 degrees, this would be 90 degrees, this would be 60 degrees. And a 60, 60, 60 triangle is an equilateral triangle. That would mean that each of my side lengths are 1. So it would mean this whole thing is 1. So what that means is that this leg, the shorter leg, is going to be exactly half of 1, or 1/2. Now remember, my goal is to get my side lengths on my 30, 60, 90 triangle with a hypotenuse of 1. This triangle is the triangle I'm concerned about. I've got a hypotenuse of 1. I've got a shorter leg of 1/2. So I really just want to find what's the longer leg. You can again do Pythagorean theorem. So I would know that, okay, so 1/2 squared, that's my shorter leg, plus x squared, that's my longer leg, is going to be equal to 1 squared. So if I simplify this, I've got 1 over 4 plus x squared equals 1 squared, which is 1. Let's isolate our x. So x squared equals 1 minus 1/4. Got to subtract a 1/4 on both sides. 1 minus 1/4 is equal to 3/4. And now I need to take the square root of both sides. Take the square root. And square root of 3, I don't really know, so I'm just going to leave it as square root of 3. The square root of 4 is 2. So square root of 3 over 2 is the length of the longer leg. Again, that proof is just kind of an FYI for those of you who like proofs, which is, probably a lot of you guys, honestly, because who doesn't like proofs? But the main thing you've got to know is that if you have a 30, 60, 90 triangle, and the hypotenuse is 1, the shorter leg that's across from the 30-degree angle, is going to be 1/2, and then the longer leg across from the 60-degree angle is going to be square root of 3 over 2. That's the big takeaway. Now what we're going to do on the next couple slides is we're going to practice with this. We're going to use the fact that the hypotenuse of each of the triangles is 1, and the relationship to the special right triangles. Now when I say relationships to the special right triangles, I mean what we did on the previous slide. We're going to label the leg lengths. Now, these next 3 slides are going to look kind of similar, next 4 slides, but it's actually going to be really useful as we start to look at the unit circle, because triangles are positioned in different ways on the unit circle, and we need to be able to correctly identify how long the legs are. So let's first start with, I'm just going to go with the middle, the 45, 45, 90 triangle. I know that this is a 45-degree angle. Also, that means this is a 45-degree angle, because remember, triangles are 180 degrees total. The hypotenuse is 1, and remember, both of the legs in this is going to be square root of 2 over 2. Right away, this is square root of 2 over 2. Okay, now the 30, 60, 90 triangle, we'll do the one where the 30-degree angle is on the bottom. So 30-degree angle is on the bottom. I'm going to look across from that side. The short leg, if you remember, is going to be 1/2. And then the long leg, so this is an implied 60-degree angle. The long leg that's across from the 60 is square root of 3 over 2. So those are my 2 leg lengths if I have a hypotenuse of 1. Now let's go the other way when the 60-degree angle is on the bottom. So if the 60-degree angle is on the bottom, look across from it. The long leg is square root of 3 over 2. And the short leg, which is across from the 30-degree angle, is of course 1/2. You try it on this next slide. So if you notice, it's the same 3 triangles, but it's just positioned in a little bit of a different way. Press pause in the video. Try to identify where the leg lengths. 1, 2, 3, go. Press pause. Do it now. Okay, welcome back. So hopefully what you did was you said, okay, here's my 30-degree angle. Across from my 30 degrees, I know is going to be 1/2. And then this is an implied 60-degree angle. Across from my 60-degree angle is square root of 3 over 2. Hypotenuse again is 1. 45, 45, 90 triangle. Hypotenuse is 1, easy money. Square root of 2 over square root of 2 for both of the legs. And now with the 60-degree angle down here, 60 degree across from the 60 is square root of 3 over 2. And across from the implied 30-degree angle is 1 over 2. Next slide. You know where we're going with this. Press pause, and then I'll meet you back and we'll check your answers. You're labeling the leg lengths. Press pause. Do it, do it. Okay, welcome back. Again, hypotenuse is 1. Across from the 30-degree angle, we're going to have 1/2. And then this is an implied 60-degree angle. And across from the 60-degree angle, square root of 3 over 2. For the 45, 45, 90 triangle, across from the 45-degree angle is square root of 2 over 2. And across from the other 45-degree angle is also square root of 2 over 2. Last one, 60 degrees. So across from the 60-degree angle is square root of 3 over 2. And then this is an implied 30-degree angle, and 1/2 is across from that. Now you can always go ahead and, if you were ever not sure that these were right, you could check with the Pythagorean theorem. I could check that square root of 3 over 2 squared plus 1/2 squared is indeed equal to 1 squared. And it is. So next one. Okay, press pause. See if you can fill in the angles and sides. I mean, not the angles. Welcome back. Across from the 60 is square root of 3 over 2. Across from the 30-degree angle is 1 over 2. In my 45, 45, 90 triangle, it's always the same. Both legs are square root of 2 over 2. And across from the 30-degree angle is 1 over 2. And this is my implied 60-degree angle, square root of 3 over 2. If we were in school, what we do is we would have a little quiz tomorrow, like a 2-minute quiz, and you'd have to fill out the sides. I know that that's a pretty simple thing, and I know that you guys did that last year, but it's just really important with where we're going with building the unit circle that you can correctly identify which sides go where and what their lengths are when you have a hypotenuse of 1. So that is the whole deal with a 30, 60, 90 triangles. We're not going to do it like you did last year where I give you different leg lengths, different missing hypotenuses, and you have to find the different sides. We're not going to do that at all. All we're doing is we're doing when you have a hypotenuse of 1. And the reason for that is because we are going to be looking at a unit circle, which is on the coordinate plane when you have a circle that has a radius of 1. So this length right here is going to be 1. And what we're going to be doing is we're going to be putting triangles in this circle. So all of their hypotenuses are always going to be 1. Like I could draw another triangle down here, for example. And because this is, again, a radius, this would be equal to 1. So that's why we're concerned about these triangles. Angular measurement on the coordinate plane. That's where we're going to put angles on the coordinate plane and talk about what they measure. And I called it at the beginning circular measurement because you kind of go around in a circle, but the better name would be angular measurement. So what this means is we're going to put angles on just a regular XY axis. Now you're always going to start your angle on the positive side of the x-axis. This is always the first side of the angle, or the initial side of the angle. So your initial side is always on the positive x-axis. And then your terminal side is the other side of the angle. So maybe I'm going to go, maybe I'll go right here. And this would be my terminal side. Terminal, think about terminal as ending. So terminal side is the other side of the angle. So the angle that I've drawn right here, the measurement would be this thing right here. So if I'm starting and I'm going in a positive direction, positive is when you go counterclockwise. So let's see, this right here would be, I know that if I stopped at the y-axis, that would be 90 degrees. So maybe I went, let's say I went 30 degrees past. So this might be a 120 degree angle. I went 30 degrees past. I think that's what I said. Okay, now the reference angle is always, you take the terminal side, and it's the angle between the terminal side and the x-axis. I should say the smallest angle between the terminal side and the x-axis. So in our first example here, let's see, if I had the 120 degree angle, so I know that this is 30 degrees right here. Let's just fill in some other degrees here. I know this is a 90 degree angle. I also know this is a 90 degree angle. So if I had gone all the way over to the x-axis, that would be 180 degrees. One way to find the measurement here is to say, okay, so this is 30 degrees. That would mean that this missing part right here has to be 60 degrees, because I know that together these make a right angle, 30 and 60. So 120 degrees, my 120 degree angle has a 60 degree, this is the reference angle. The reference angle, A-N-G-L-E. Let's look at another angle here. Let's erase what we have. And before we even look at another angle, let's first just label the X and Y axis and what their measurements are going to be. I know I'm going to annoy some of you so much because there's some dots there. Okay, I think I got them all. So let's start with this. I know that this is 0 degrees because that's my starting amount. 90 degrees up here because that's just one 90-degree angle right here. And then 180 degrees over on the negative y-axis because that's two 90 degrees. Down here on the negative y-axis, you would add another 90 degrees, and that would take us to 180 plus 90 is 270 degrees. And then add another 90 degrees, and that takes us all the way back to 360 degrees. So this is also 360 degrees, 0 degrees or 360 degrees, either way, because you could either start here and not go anywhere, and that would be 0 degrees, or you could start at your initial side, go all the way around, and that would also be 360 degrees. So same thing. And notice again, positive measurement is when you move counterclockwise. If I start at my initial side and I go this way, that's positive measurement. Negative measurement would be starting at the same place, starting at your, let's do some erasing here. Negative measurement would be you have the same initial side, but if you move clockwise, so for example, this would be a negative 270 degrees because I am moving clockwise. So negative measurement is moving clockwise. So I'm just going to draw a couple different angles here and we'll talk through what their reference angles are going to be. Let's draw a 210 degree angle and then talk about what its reference angle is going to be. So we're going to do a 210 degree angle. So we're going to always start in the same place. Always start at your initial side. There's your initial side. 210 degrees, I am going to have to go, it's a positive, so I'm going to be moving this way. I'm going to be moving counterclockwise. Now, 210 is past 90, so I have to go past the 90 degree. It's past 180, so I also have to go past the 180 degrees. Now, how far is it past 180? Do 210 minus 180, and that would get you 30 degrees. 30 degrees. So that means that 210 is 30 degrees past the 180. So I have to go 30 degrees past the 180. I'll say that's about like here, maybe. And so this angle right here, the green angle that I just drew, this is a 210 degree angle, and it's positive because I'm moving counterclockwise. Now the reference angle, remember the reference angle is the smallest angle between the terminal side and the x-axis. So this is my terminal side. That's my terminal side, and I'm just going to go right to the x-axis, and what's this? This little orange angle right here, this is my reference angle. And we kind of already talked about it in making our angle, but I know that it's 30 degrees past the 180, so my reference angle for this is 30 degrees. I have a 30 degree reference angle. Let's look at another angle. I'm going to erase here. So let's erase my 210, and let's do let's get all the marks here. We're going to do let's do a 295 degree angle. Let's try that. 295 degree angle. So we'll draw the angle and then we'll find its reference angle. So initial side always, positive, negative, whatever. This is my initial side. 295 degrees. So if you're trying to think what quadrant it's going to be in, first quadrant, second quadrant, third quadrant, fourth quadrant, you're going to have to go past 90, past 180, also past 270. Now to see how far past 270 it is, do 295 minus 270. And you're going to get 25 degrees. So that means I have to go 25 degrees past this point right here. So I'm going to do a pretty small angle right here. So this is 25 degrees. Okay, so there is my 295-degree angle. And some of you guys might be starting to see why I call this circular measurement, because I kind of make circles here around the axis. So now let's talk about what our reference angle is. The reference angle is the smallest angle between the terminal side and the x-axis. So it's very important to remember, this is the y-axis. I'm going to do y-axis in orange and the x-axis in blue. This is the x-axis. So when I'm talking about a reference angle, I don't really care about the 25 degrees. What I want is I want this angle right here between the terminal side and the x-axis. So this is my reference angle. And I mean, I'm just thinking of right away, there's two easy ways to find this. You could say, okay, so I know that if I were to have not stopped at the 295 degrees, but if I were to keep going all the way around, that would be all the way to 360. So one way to find the reference angle would be to do, let's do 360 minus 295, and you get 65 degrees. Another way to do that would be to say, okay, I know that, let's draw in maroon here. I know this whole section is 90 degrees. So if this whole section is 90 degrees, 25 degrees makes up part of the 90 degrees. So if you do 90 minus 25, you also get 65. So either way, my reference angle is 65 degrees. All right, let's do another one. I'm going to erase everything. Let's do one that is, let's just do a 70-degree angle and talk about its reference angle. Erase all the way. So that was our 295. Let's do just a regular 70 degrees. So as always, 70 degrees, initial side right here, you're going to go 70 degrees. So 70 degrees doesn't even get passed out of the first quadrant. 70 degrees right here. This is 70 degrees. And your reference angle, check it out, your reference angle is also 70 degrees. The reference angle is equal to 70 degrees. Let's do a negative one. Let's go negative, let's just do negative 200. How about that? Negative 200. And you are more than welcome. Pause the video. So draw the angle, negative 200 degrees, and then find the reference angle. Negative 200 degrees. Initial side, as always, right here. We're going to have to go, now when we're going negative, this is negative 90 degrees. This would take me to negative 180 degrees. So if I'm doing negative 200 degrees, I'm going to have to go past this just by 20 degrees. Now, because I'm moving in a clockwise direction, that's what makes it negative. And you only went 20 degrees past. So my reference angle is 20 degrees. That's the reference angle, 20 degrees. For our last 4 slides here, we are going to try to find an angle so that you have a 30, 45, and 60 degree reference angle in each quadrant. So this is quadrant 1. We've got, here's my x-axis, here's my x-axis, here's my y-axis. Keep in mind, this is always going to be your initial side right here. So I want to have a 30 degree, a 45 degree, and a 60 degree reference angle. So this actually, it's not harder than it seems. Here's my 30 degree angle. So it's a 30 degree angle, and I'll draw the angle measurement kind of out here at the end. How about that? And then the reference angle inside. So in my quadrant 1, I've got a 30 degree angle and it's got a 30 degree reference angle. That's all there is to it. For a 45 degree angle, got a 45 degree angle, so it's a little bigger than the 30, so it's a 45 degree angle and a 45 degree reference angle. 60 degrees, so 60 degree, I've got again, initial side is always in the same place, and I'm going to go 15 degrees past my 45, so 60 degree angle right here. And that's all there is to it. So in quadrant 1, the 3 angles that have a 30, 45, and 60 degree reference angle is just that, 30 degree, 45 degree, and 60 degree. Let's go to quadrant 2. Quadrant 2 is drawn right here. This is quadrant 2. Now keep in mind your initial side is always going to be the same. So I think my last one I did 30 in red. So initial side is always the same. And I'm looking for, I want to make an angle that has a 30-degree reference angle. So keep in mind this right here is my reference angle. So I want this to be 30 degrees. So we got to figure out what is the measure of this whole angle. One way to do it would be to say, okay, so you know that this is 180 degrees. So I need to do 30 degrees before 180 degrees. So do 180 minus 30, and this would be 150 degrees. So if you have a 150 degree angle, then it has a reference angle of 30. All right, now let's do the same thing, but let's do a 45. I think last time I used green for 45 or blue. I used blue. Okay, so now let's do a 45-degree angle. Initial side, always same place, but now I want to make my terminal side have a reference angle of 45 degrees. So what angle is that going to be? Let's see. You're going to have to do 180 minus 45. If you do 180 minus 45, you get 135. So that means that my 135-degree angle has a reference angle of 45. Last one, we want to have a 60-degree reference angle. So 60-degree reference angle means that, again, our initial side is here. I want to have a 60-degree angle between my terminal side and the x-axis. So I want to do 180 minus 60, and you get 120. So if you have a 120-degree angle, that means it's 120 degrees between your initial side and right here. Like this is 120 degrees. 120 degrees has a reference angle of 60. All right, let's do the next quadrant. Quadrant 3. So quadrant 3 is down here, and I'm just going to label again. This would be 0 degrees. This would be 90 degrees, this would be 180 degrees, this would be 270 degrees, and then all the way back to 360 degrees. Your initial side is always right here. So I am looking for the angle that has a 30-degree reference angle. So one way to think about that would be initial side's right here, and then I want to make a 30-degree angle with the x-axis right here. I want this to be 30 degrees. And then I'm trying to figure out what's the measurement of this whole angle. One way to do it would be to say, all right, you're 30 degrees past 180, so do 180 plus 30, and you get 210. That was a little goofy. 180 plus 30 is indeed 210. So 210 degrees has a reference angle of 30. Reference angle of 30. Now let's do the 45. 45, I think we used blue. 45, so initial side is the same, and then I want to make a 45-degree reference angle. So I want this to be 45 degrees. And I'm looking for what's the measurement of this whole angle. So again, it's going to be 45 degrees past 180. So do 180 plus 45. 180 plus 45 will give you 225. So that means this is 225 degrees, and 225 degrees has a reference angle of 45. Last one, 60-degree reference angle. So initial side is the same. I want to make 60 degrees between the x-axis and my terminal side, and I want to know what's the measurement of this whole angle right here. You see the pattern. Do 60 plus 180 because I'm 60 degrees past the 180, and if you do 60 plus 180, you're going to get 240 degrees. So 240 degrees has a reference angle of 60 degrees. All right, last quadrant. Here we go. Quadrant 4. Quadrant 4 is down here. Quadrant 4 is down here. So let's put again, this is 0 degrees or 360 degrees, either way. This is 90 degrees, 180 degrees, and 270 degrees. So we're looking for the angle that has, I'm starting here, I've got an initial side here, and then I'm going to go all the way around, and I want to have a 30-degree reference angle. So that means this little section is going to be 30 degrees, and I want to know what's the whole measurement. So I think the easiest way to do it would just to be, let's do 360, which it would be 360 if you went all the way around. Do 30 less than 360, and that would be 330. So 330 degrees has a reference angle of 30 degrees. And then now we're going to do a 45. So 45, initial side is the same. I'm going to go all the way around, but stop a little bit before because I want to have a, whoa, that line got a little weird. I'm going to have a 45-degree reference angle this time. So again, do 360 minus 45 because we stopped 45 degrees before going all the way around, and that is 315. 315 has a reference angle of 45. Last one, if I'm making a 60-degree reference angle, so again, initial side is here. I'm going to go all the way around and stop just a little bit short. This is going to be 60 degrees, and then do 360 minus 60 to get 300. That means that this whole thing is 300 degrees. And 300 degrees has a reference angle of 60. All right, we're going to put this all together next week with the unit circle, but for now, I hope you enjoyed your math time.